so let's look at number 3. We're trying to find the volumes of these revolving regions, and these are the axes that we're going to revolve them around. Notice that we have 3x squared, 0, and 2. So y equals, and x equals are the functions that we're given, and then we're going to rotate them about y-axis, x-axis, y equals 12, and x is equal to 2. So I've already drawn this picture, and it's a three-dimensional drawing where the red function is our 3x squared, the blue function is y equals 0, and then we have x is equal to 2 is that vertical line. Now again, this is like from an angle side view, as if you were looking down, but notice how I have the z-axis, especially dashed in that gray region, so that you can kind of see that right here in this gray region, it's like behind this plane. So it's just trying to give it a little bit more dimension so that you can visualize how this is going to look like, okay? So we want these to revolve around the y-axis for the first one. So that means this region over here that's shaded like orange, we're going to rotate that about the y-axis over here. Okay, so it's like going to come out of the page and then go around the y-axis. Notice that those are parallel with the x-axis, so those are going to be dy. So when we go to build that, these are going to be dy. Okay, and because there's void or like space between this orange area and the area in the axis of revolution here, then it's going to be a washer method. Okay, so it's not saying that the area is touching everywhere where the axis of revolution is. No, there's some gaps or space. That's why we know it's going to be a washer method. So we'll say big R squared, big R squared minus little r squared, and it's pi, constant multiple ruled out in front. Now, if we wanted to revolve it about the x-axis, this would come out of your page and go underneath. It would come out of your page and go underneath. And notice that these slices are parallel with the y-axis. So these are vertical slices, so they're going to be dx over here for part B. Okay. Now, whenever it was revolving, and in this case, the x-axis, this is going to be touching. You see that it's touching right here, all along its axis. It is touching that shaded region. So there are no gaps. You know, when you create this three-dimensional piece, after you rotate it, there aren't going to be like any holes in the center or gaps. So this is going to be the disk method. So it's just 1 pi r squared. Okay, so pi r squared with only one radius to worry about. Now, these other ones, we're going to go ahead and put these and draw them in now. We have y is equal to 12. Okay, so we could say like 12 is way up here, per se. And then we're going to say y or x is equal to 2. Okay, so x is equal to 2 is already that green graph. So let me go ahead and leave that there as is, but I'm just going to label this up here as y is equal to 12. Okay, and then I will go ahead and change this to be x is equal to 2 because that's already a function that we were given that has already been drawn on the graph. Okay, so if I wanted to revolve this orange region right here, this orange region around y is equal to 12, it would like come out of the page and then go around like this. Come out of the page and then go around like this. That's what's happening as far as it to rotate. And notice those slices are parallel with the y-axis. So those two are going to be dx slices. So let's go ahead and write that down here. And they have gaps. They have a gap in between this orange shaded region, and all of this right here is going to be a gap or empty space because it's going to revolve around y is equal to 12. So that's going to be another washer method. So to be pi big R squared minus little r squared, and it's going to be dx because they're parallel with the y-axis, aka vertical slices. And then last but not least, we have this revolving around x is equal to 2. Okay, so x is equal to 2. It's like going to come out of the page and kind of dip back around. It's going to come out of the page and kind of dip back around. So it's hugging the axis of revolution. That means the entire area is touching this axis of revolution. There are no gaps between the area and the axis of revolution. So therefore, this is going to be a disk method. But because they were horizontal, aka parallel with the x-axis, these are going to be dy's. Okay, so let's go ahead and write that one out. So pi r squared, because it's disk method with no gaps, but it's dy. I wanted you to see all of that just to set them up so you can compare and contrast what's going on between each one. All right, so now, next order of business. Let's look at our graph also on a calculator in case that some of you scale-wise want to make sure that the graph is accurate. So we'll say 3x squared is f of 1. We'll go to tab. We'll say y is equal to 0. So this is my axis right here, or my graph of what it looks like. And you see that in the drawing. Only the graph is red and the x-axis is blue. But nonetheless, it's still the same picture. Okay, so what we're going to do is, for this first one, let's go back to the drawing. When we rotate this about the y-axis, we need to develop what is big R, what is little r, and so on and so forth. So what I'm going to do is I'm going to show you how you should draw this. And I wanted to show you in real time, not already having it drawn. So if I'm revolving about the y-axis, that means I'm going to go to the y-axis, and then I'm going to go to the furthest outermost piece of this shaded region. Okay, so notice I went from the axis of revolution, which is the y-axis, all the way to the furthest outer edge of that shaded region. And if I wanted to see what is that as far as a length, well, I know that this is going to be in terms of y because it's horizontal, not vertical. Okay, so I need to look at this green function that it's touching and the y-axis itself, and I know those to be x equals 2 and x equals 0, and I need to write those in terms of y. Okay, so if I were to look at that, that means I'm going to solve for x. So when you write something in terms of y, okay, so again, let me show you. This is in respect to y. That means these better be a bunch of constants and y's. This is in respect to x. That means only you could put constants or x's over here. The same thing, x's go here because it's in respect, and because it's in respect to y, it has to be written in terms of y. So let me write this down real quick so that you understand. In terms of y, so we'll say in terms of y, we're going to solve for x. That means get x alone. In terms of x, that means we're going to solve for y. Okay, so for this first one, we want them in terms of y. That means we got to get x alone, which it already is. X is equal to 2 and x is equal to 0, which is that y-axis itself. So when I'm looking at this green graph right here, this line that I've drawn, I want to look at it like what's the top minus bottom. So I do have to rotate my head. So if I rotate my head, I want to see like the green function is going to be on top. Again, imagine yourself rotating your head 90 degrees to where as you're looking at it, then like this part becomes the top. So when you look at it, you're going to see that the green function is your top function. So it's going to be 2 is your top function. So it'll be 2 minus the bottom function, which in this case is the y-axis. You're just going to put minus 0. So the top minus the bottom, that is big R. Now, if I go over here, and from the axis of revolution, this time I'm going to go to the inside function. Not all the way to that green line, but to the red graph, I'm just going to stop right here. Okay? So when I stop right there at the red graph, I want to ask myself, how would I show this as far as a length? Okay? So again, we're going to rotate our head to where this right here is the top again. And now my top function of that purple small little radius that I drew is the red function itself. Okay, so I'm going to be working with this red function, and I want it in terms of y. That means I have to solve for x. So let's go ahead and take y divided by 3 is x squared, and then the square root of that is going to be x. I've solved for x, and this right here is representing that small little purple radius that I drew over here on the graph, okay? That is the length of that. So if I were to write this out, I could write this is like x, if you will, this x right here, okay? All right, so that's going to be the top over here that we say y over 3 all square rooted. That's the top function. And then we're going to subtract that 0 again. Okay, we're going to subtract that 0 again because that 0 is the axis that we're revolving around. Okay, so top minus bottom, and that squared, that's how you would set that one up. Okay, so now let's look at the shaded region that we have, and this time we're going to revolve it about the x-axis. Okay, so let me kind of over on top of this reshade my base area of that orange, because that's all we're looking at again. And now we're going to revolve it about the x-axis. So imagine this just coming out like before, revolving around the x-axis. Okay, so let's go to create our big radius. So from the axis of revolution, that's the x-axis, I'm going to go to the furthest edge of that area, okay, which in this case is going to be the red function. Okay, so now the red function, I don't have to rotate my head to find out what the top and bottom are. When I'm doing dx, I can look at it exactly how it is. So the top is still over here, dxy's. Okay, so dx are vertical slices or parallel slices that are parallel to the y-axis. My top function is the red one. Okay, so the red one is going to be now in terms of x. Okay, so that's the top function. And I'm going to subtract the bottom one, which in this case is the blue x-axis. Otherwise, y is equal to 0. So I'm just going to subtract 0. So the top minus the bottom, that's the radius. And because this isn't a washer, that's it. We're done. Okay, so it'd be 3x squared minus 0. And what I'm going to do right now is I'm going to back this thing up just a little bit so that we can do the next question. And so that you're not confused as far as what's going on. Let me just quickly write this back in as far as what our answer is going to be. Our top is 3x squared, and we're subtracting that bottom, which was the blue function of 0. And all of this was that radius piece that we were doing with just one radius. Okay? All right, so let's now go to part C. We're going to revolve it about y equals 12. That means it's going to come way out here and then dip around y equals 12, and then come way out here and dip around y equals 12. So again, that's why we have these dx slices, because they're parallel to the y-axis. But I'm going to show you how you're going to have to show this big radius from the axis of revolution all the way to the outer rim. And then look at this from here and say, what would the top minus the bottom be? Okay, so these are vertical slices, so we don't have to rotate our head. This is still going to be the top. And the top function is going to be 12. Okay, the top function is going to be 12, and the bottom function is going to be this y is equal to 0. So it'll be 12 minus 0 as far as the top minus the bottom. Okay. So, and then when I go to do the smaller one, again, I'm going to go from the axis of revolution because that's what I'm revolving it around. And then we'll go to the inside radius, which is the red function. So we're going to stop whenever we touch the red function. Okay. Now looking at this, if I said what's top minus bottom, again, we're not rotating our head. Our top function is 12. And our bottom function is going to be this 3x squared. Okay, so that's how we're going to set those up. So let me back arrow key because I'm going to do the last one here in just a bit. And then I'll type in, or I'll write in, the top function was 12. The bottom function was 0. And then the top function was 12. And then the bottom function was the red graph of 3x squared. Okay, be cognizant on those parentheses that all of this is squared, all of that is squared, All of this is squared, this is squared, and that is squared, okay? All right, so now our last one, x is equal to 2. We're going to take this now and revolve it about x is equal to 2. So it's going to come out of your page and then dip around like that, okay? So these are dy slices, otherwise parallel to the x. And if I draw it, again, I want you guys to get into good practice. Draw the radius from the axis of revolution, which in this case is 2. And then we're going to take it to the outermost rim of that shaded region. So look at that orange shaded region and go out to the furthest edge. Okay, so now I have this green and this red graph touching. And if I'm just looking at this small little radius, because remember, I'm revolving this about this x equals 2. All right, let me make that a little bit smaller. This is disk method because you don't see a void. This is going to revolve like that. Revolve like that. Okay. We want to tilt our head to the right to where this becomes the top again, so that our top function is the green function, which is in terms of y because we've solved for x. So the top function here is going to be 2. Again, this is from rotating your head. And the bottom function is going to be touching this red graph that was over here. Okay, that's the bottom function. But we have to write that in terms of y. Okay, so that means we have to solve for x, which we've already done from part A. So that's going to be the square root of y over 3. And all that is going to be squared. So guys, this is how you set it up. You can plug it into the calculator to get your answers. For the sake of time, I'm not going to go through that. But make sure that when you do put in your problems, that whatever you are setting it in terms of and in respect to, that you're using the dx or the dy. And that's how you should get your answers for those there. All right.